Hello, my name is Sanga Emmanuel, and I'll be presenting on the experiment 6, which is vapor liquid equilibrium. I'll be presenting on the working principle and methodology of the experiment. So to begin, the working principle is made up of mainly two methods, which are the vapor recirculation method and the condensate recirculation method. For the vapor recirculation method, a pump recirculates the vapor through the stationary liquid by way of heat interchange system until the steady state is attained. Then the temperature, pressure, and compositions of the liquid and vapor phases are measured. The vapor recirculation method can be demonstrated by the diagram in figure 1. In continuation, for the condensate recirculation method, the vapor leaving the equilibrium chamber is condensed and the hydrostatic head of the condensate provides the required pressure differential. There are two operational modes that can be distinguished in this method. We have the first, which is the vapor. The vapor condensate re-enters the equilibrium chamber as liquid, and in the second mode, the condensate is re-vaporized in a heater, which is shown in the figure 2 as Q, and then it re-enters the chamber as vapor. The principle of operation of all the steels employing circulation of the vapor phase condensate is illustrated in the figure 2, and the liquid sample is in the equilibrium chamber E, which is boiling, and the heat is delivered continuously by the heater Q, and the vapor is condensed in the cooler Q2, and it returns to the equilibrium chamber through the condensate container K. The valve Z is used for removing the inert gases or air from the steel in the early stage of the operation. Below is a video that demonstrates or explains the procedure for the operation of the equipment for VLE process.
Okay, here we got the bouilliometer. It's generally used to measure the alcohol content in wine. But we're not going to do that in ULab. What we're doing is we're using it to measure the vapor liquid equilibrium data for ethanol and cyclohexane.
So here we've got the reboiler. We just call it the pot usually, where we're boiling the mixture we've got. The vapor comes up through this area up into the condenser here, where it all condenses, falls back down through here, and then is fed back into the reboiling pot. And here we can take samples of the distillate, and here we can take samples of the liquid. The distillate tells us kind of what our vapor composition is, and this can tell us what our liquid composition is. Now to get this thing started, first we need to turn on the cooling unit, which is this bad boy right here. We just turn it on, and it's already set to 10 degrees, which is where we need our condenser to be operating. You want it to hit that temperature long before you turn on the reboiler here. The way you turn this puppy on is you first turn this switch on and then push start, and it'll try to heat it up to the moment that it starts boiling, and then it'll just hold that temperature. Pretty simple, pretty straightforward.
All right, so with the experiment, we're trying to find some parameters for a vapor-liquid equilibrium. And with those parameters, we're going to find the Wilson coefficients for this mixture. And with those, we can find out how this will mix, and we can design a distillation tower off that data.
So the biggest problem we tend to run into when running this thing is when we're collecting the liquid down here to try to get its composition. You notice that the distillate is coming down through right here. And so if you're not careful, you can end up getting some of the distillate in there contaminating your liquid, and you'll end up just reading the distillate composition. So what we do is we first open this valve this way so it only drains from here, and we purge it about 15-20 milliliters into a waste receptacle, and then, only then, do we take our liquid sample.
After we take the samples of the distillate and the the bottoms composition. We come here, we insert the sample into this receptacle right here. We put the lid over it. We fill about halfway full, put the lid over it, and all you do is hit start. It'll give you the refractive index. After which we go and we have an Excel sheet provided to us on the problem statement, and we use that to convert that to composition.
The experiment is set up as shown. On the left, we have the oscilloscope, which is the instrument or equipment used for the vapor-liquid equilibrium experiment, and on the right, we have the instrument or the refractometer, which is the equipment used to measure the refractive index of the samples. So for the vapor sample valve, it permits us to collect the distillate samples that helps us to analyze the distillate or vapor composition. And for the liquid sample valve, it permits us to collect liquid samples that we can analyze to get the liquid composition of the mixture. For the experimental procedure, the experiment was carried out as follows. First of all, we prepare 5 mixtures of methanol and water according to the volume ratio. Then we take the refractive index of each of the mixtures and record them as the liquid phase before heating, before the mixtures are being sent to the heater. After which the valve V1 and V2 are open and the mixture of the beaker 1 is poured into the distillation tank slowly. When all of the content is already in the heater, the valves V1 and V2 are closed and then the heater is switched on. The boiling point reading is then taken and recorded when there is the presence of vapor detected at the output tube of the distillation tank, and it is switched off then. Then V1 is open to collect the vapor product of the distillation, and the refractive index is taken and recorded as the vapor phase. Then V2 is open to collect all the excess vapor product, and valve V3 at the bottom part of the distillation tank is open to collect the liquid product after heating, and the refractive index of the product is taken and recorded as the liquid phase after heating. Now then, the steps from 3 to 7 are repeated for beaker 2 to the beaker 5 to have multiple results and compare. As the results of the experiment are determined, the process flow diagram for the entire vapor-liquid equilibrium system is drawn, and the process is explained thoroughly. The graphs of the refractive index, that's before heating versus the mole fraction of the methanol, is plotted. Then the temperature XY diagram of the methanol water system is plotted, and the result is compared with the literature results. That is, the experimental result is compared with the theoretical or actual results. And finally, the vapor liquid equilibrium diagram is then described.